Okay, I'm going to do problem number 6. We have actually a projectile problem. They're wanting us to graph a couple of things. I just went ahead and drew the graph here. They had a position graph in terms of x and y, and they showed the 5 dots or 6 dots here. So I just went ahead and showed those 6 dots, and then I gave the numerical value, the x, y coordinates of each of these. It's easier than trying to draw it on what looks like I don't have graph paper here. Now, what are they asking us to find? Part A, they want us to make a position versus time plot. B, they want a y position versus time. C, they want us to graph the x components of velocity with respect to time. And then D, they want the vertical component of velocity with respect to time. So let's go ahead and do part A. So they want position versus time, x position versus time. So it's actually pretty easy. And by the way, this was starting at t equals 0 over here. I know that because the arrows are all pointing to the left on the curve. So t minus 0 is here, and I have 1, 2, 3, 4, 5 increments of time. So for each of these increments, I pretty much just pick off what the x value is and plot it. So at time equals 0, I'm at -10. And then at the first dot, I'm at -8, which I guess is about right there. And then I go to -6. And then I go to -4. I'm not doing this very well. I think I'm drawing. Obviously, by the time I get over here, I'm going to be at 0. So let's try that again. -10. I know I can tell it's going to be a straight line, so it's going to be -8, -6, -4, -2, and then I'm back down to 0. So that is the position versus time, just literally read right off the graph there. Why did I say negative? That's not negative. They're moving in the negative direction, but it's positive. Grumble. So take the same thing, mirror image it. We start from 10 and we go down to 0. Positive 10. So it was 8, 7, or 6. Why did I say negative on all of those? My goodness, you were probably all wondering the same thing. I know, I certainly was wondering that. I was just checking to see if you were paying attention, really. Just kidding. Okay, so that's my position, x position versus time plot. Alright, so let's go ahead and look at B. B, they want y position versus time. So again, I can just read it off the chart, and theoretically this time I will read it correctly. Let's look over here to get my units. Y is changing from, over here at time 0, it's going from 0 up to about 3, and then back down to about 0 again. This is time, and this is my y position. So again, at time 0, I'm at y position of 0. At 1, 2, 3, 4, 5. At time 1, I'm at positive 2, and then I go to positive 3, and then I stay at positive 3, and then I come back down to positive 2, and then I come back down to 0 again. So basically it's making a curve like this. That's not very neat. It should be more uniform, but you get the idea. It'll look better when you do it on the computer screen. Alright, the next thing I want us to do is vertical and horizontal component of velocity with respect to time. So let's look at that. Okay, so we want to draw our velocity versus time. Now maybe I should have looked at this first to see, is my velocity going to be positive or negative? Well, I am starting over here and I am moving to the left, so by convention that would be negative velocity, which means I should have drawn it like this because I'm going to have negative velocities. Alright. So what's my velocity going to be at time 0? Need to look at the chart here, make sure I'm reading something correctly. Okay. Alright, well, remember that velocity basically equals the change in position over the change in time. My pencil's dying here. So let's look at our graph. Let's look at our graph up here. To estimate the velocity, I can start by estimating the velocity between these 2 points right here. How much is the change in the x distance between point 0 and point 1? I could also look at this chart. But what I'm seeing is that my x position is changing by 2. It's actually -2 because I'm going in the negative direction. So my change in position is 2, and we'll just say unit of time, so my velocity is actually -2. 2 units of distance divided by time to the left. Now if I look at each of these, I see that that's the same for each one of these, and of course we saw it here. It doesn't change. I'm changing by 2 units of position for every increment of time. So what I see is that my velocity is actually constant. So my chart here, I expect, is going to be a velocity of -2, and it's going to stay -2 all the way across. Now what about my vertical velocity? Well, this is a projectile, a variation of free fall we were doing in chapter 2. It starts up, it goes up, at some point obviously the velocity equals 0, and then it turns and starts to come back down again. So I'm going to expect the velocity to be positive but decreasing, approaching 0, and now reversing, it's going negative, and the magnitude is increasing as it comes back down. So let's go ahead and draw my chart. So here's my, and I do expect it to be positive. So can I calculate what that velocity would be? I know generally speaking it's going to have some kind of a relationship like this, right? It's going to start positive but decreasing towards 0 and then continuing negative. So at what point here does it cross the 0 point? Well, we know that of course is between points 4 and 6, so most likely right at about 0.5. So at t equals 5, it's probably about right there. Now what's my initial velocity? Well, again, I can come and look here, or I could look here. The velocity is the change in distance over the change in time. So what was this right here? How much did we say the y distance changed? It moved up by 2. This was 2, this was 3. Okay, so the change would be the same on this side because that's not drawn very well at all. So this is 2, change in distance is 2. Let me come back down here. Velocity y is going to be delta x in the y over the change in time. And what was the change in y? We saw 2 units and time was 1, so the velocity is 2. So it's starting here at a value of 2, decreasing down to 0 at about time 5, and then continuing to increase down that way. So my chart's going to look something like this. You of course are going to put in the multiple points here, but that's going to be the shape of my curve.